Of the merits, possibilities of the methods, and also how it works. And I want to go a little bit more into the ability to do this also yourselves, and also in an operational sense. I have a small company called Velocimetry, and that was actually initiated as part of one of the innovation calls of the hydro of WMO. And we started developing OpenRiverCam really with the idea that to really facilitate basically users, people that have real world problems, to conduct these kinds of analysis themselves in any country, any environment that you like. So you have this stream, and then you want to convert that into something useful, the river flow and the estimates that Salvador already mentioned. Now, and then you can think of this, that kind of methods you could put into a service, and many people could do that, entrepreneurs, companies, yourself. But the reason to do OpenRiverCam is really to facilitate these surface water observations for everyone, but also by anyone. That anyone can conduct this in their own environments. And that also led to sort of, my ambition is really to contain this in open knowledge. That is key. So software is a part, but also documentation is important to me. Broad training, I want to focus on that also a lot. Entrepreneurship, I'm exploring that. I kind of stimulate that entrepreneurs start to implement their own services in their own country with the software as sort of a backbone. And that then hopefully would lead also to more sustainability of these methods. And so on the right side you cannot read this, but there's a whole list of sort of use cases. As a hydrologist, I want to do this so that I can solve a problem, and then I need something. So I try to collate a lot of requirements for hydrologists, environmental scientists, working in institutes, etc. And I'm sort of developing the software in such a way that these use cases can really be accommodated. So now, what is it then? It sounds a little bit cryptic still, probably. It's really an entire software ecosystem, not just one package or something, but really an ecosystem that allows you to observe flows from videos and do that at any level you want. And so you can, for instance, we have a Python API to all sorts of methods. You can take that, implement your own applications on top of that. But we also have a platform in which you can collect live videos coming from different sites into a central place with a central database and a central administration interface. And from there you can connect dashboards, SCADA displays, etc., etc. And that is really in the fulfillment of those use cases, to make sure that people can really use the methods for the problem that they have. Now, a strong development at this moment is it's very difficult to see in the light, but really to allow people to have many different sites. And you can see here the little box that I showed yesterday. This is an earlier version of it as an example. And like really an edge device that does the computations on site and then posts that on a more central platform that could sit on premise in a server in your office, but it could also sit in the cloud. And there it reports, and you have real-time data available every 15 minutes or 30 minutes or 1 hour, just depending on how frequently you want to observe. So, and I'm building this at the moment. So the dashboard with the API is already available, and especially the control of how to configure do the calibration that Salvador already showed. And we're working a lot on that now to make that, to really facilitate that part on site. I'll show a little bit more about that in a later slide also. Now, we also did quite some validation of these methods to make sure that it really also works, of course, and gives accurate results. We've been briefed about that for time. An interesting thing is that we also did validations on drone footage, like what was collected yesterday. And there are actually many potential users that really want this information in a geospatial sense. So, for instance, for understanding where in space really velocities are higher and lower, for understanding environmental or ecological conditions, or to allow for assessing sites for hydrokinetic suitability, for instance, small hydrokinetic structures. So that is actually possible because all the information, if your control points are actually geospatial, and like yesterday we had control points that were measured in UTM coordinates, then also your outputs will also be geospatial. So you can plot them on a map in a GIS system and combine them with other GIS information. Some more validation we did also over a tidal estuary in the Netherlands, where there's very strong variability in flow situations over the day. Also to see how well the system is capable to distinguish when there is no information on the surface, when there is very low flows or no tracers, versus conditions where you do have a lot of information. And make sure that you then also can really assess during the day which videos were really containing information and which not. That is quite important to know, because with poor lighting conditions or little tracers, it is also important to acknowledge that, for instance, this estimate here, you can almost not see it. It's a bit transparent, and that is because a large part of the cross-section was not, there were no tracers in that part, and no information was visible there. So we need to do a lot of infilling to get the total estimate. So probably that one is less reliable, but also you could have a video that is just not very good or poorly illuminated, and then you get a large error bar also. So also acknowledging the uncertainties I consider to be a very important part of this analysis, and we also report that in our software. So some operational examples. So we have a sort of a continuous pilot site in Limburg. We work together with the water board of Limburg in the south of the Netherlands. And this also shows you a little bit the similar things that Salvador already showed, that once you have set up a camera, you leave the field, you've done your field work, you did your calibration of that alpha, that famous alpha value that Salvador already pointed out, and in a very short time you can collect a lot of information. So here you see water level and discharges collected from that camera site. And you see also the hand measurements done by the water board. And if you compare that, so they probably thought that this was an outlier. So they drew their own rating curve like this, but probably it was not, because the videos actually show that there is some sort of dual distribution function here present, and that also you can see that in the field. You can see that the profiles changes actually at that water level. So it really gives you a lot more information than just a few point measurements, spot measurements that you might take once a month or once or 2 months when you're at the site. So the live platform, we call it live OpenRiverCam. So that is the API that I mentioned that can collect information from many sites. Just a few examples. It's really, the API is central, and you can also go to an administration dashboard to remove values that you're not interested in anymore, or see time series or download things. And these are just some examples of snapshots from this morning from 2 sites that are operational. This one we actually installed together, Salvador and myself, in Switzerland 2 weeks ago now. So that has been running since, and collecting information every half hour. At the moment only during daytime. Nighttime is in principle also possible with IR illuminated cameras. Just to give you a feeling out, so yesterday I already showed you a fixed setup. Ideally you place it a little bit higher than what we showed yesterday. But the nice thing is that if you have a clearly identifiable wall, like a vertical structure, or even a staff gauge, or something that is clearly distinguished itself from the water, you can also do optical detection. That is quite nice, and also already possible with the software. Now, that small box that I showed, we're currently working on interfacing, so that that whole calibration process with the control points that Salvador explained, and you've seen probably yesterday a little bit, it can then actually be done on site. So the idea really is that you take your hardware. It doesn't necessarily have to be this box set. It can also be any hardware setup that you make yourself, as long as it has a small processor on site. You can install the software. And the idea really is you go to the field, you aim it, you do your control measurements, and then you feed everything into the device, and then you know once you leave the field that everything is working. The device is rotating every half hour or 15 minutes to capture videos and analyze those, and you also see the results popping up in the API at the central place. And then if you're really in a remote area, you want to make sure that everything works before you leave the field, and also your measurements are properly done. Now finally, I'm almost through, I think. Yesterday we did some quick setup and measurements. Yeah, the difficulty was a bit that the cross-section was, we didn't really receive a full cross-section yet at that stage. So we had to guess a little bit the cross-section, so probably the discharge values are not super accurate. But we did get some information, and you can see on the top that the first video, this was one of the first I took, was about 22.2 cubic meters per second, and then the last one estimated to be 24. And if you look very clearly, you can see this rock here is here not submerged, and here it is submerged. And so indeed the flow has gone up. You can see that in the water level already. And probably it's a little bit higher than what we show here, because I did not know the water level variation, so I had to assume a single value here. But if we would have had that, we would have had a more accurate estimate also. Okay, I'll skip this one. So yeah, some scheduled releases. By the end of the year, we probably have that operating system ready on that you can install on a device. And then you really have a fully fledged system that you can operationally and scalable operate and with your own system, everything open source. So yeah, I'll leave it with that, and if you have questions, please contact me. My contact details are below. So that's it, thanks.